Okay, this is AP Calculus Practice Exam 2. Alright, we left off, the video cut off at number 83. So 83 says the graphs of f prime, g prime, p prime, and q prime are shown below. Which of the functions f, g, p, or q have a relative minimum from a to b? So I don't know how well you can see this on the video. If you'll follow along, you turn the page over, you see that we have four graphs, okay? And we know that a minimum occurs when the graph of the derivative goes from negative to positive, okay? And the only one of these four that goes from negative to positive is the first graph. Okay, so that goes from negative to positive. The second graph, positive to negative, so that would be a max. Alright, the third graph goes from positive to negative, and then the fourth never even gets into positive territory. Okay, so maybe on your paper, if you're going back to try to study this, alright, you can write something like min occurs when f prime, okay, the derivative goes from negative to positive. So that only occurs on those options on graph of f. Right, so our f prime, so that would be option A. You remember when we did our sine line, right, and we had that we'd have a critical point C, and in this case we're going from negative to positive. Okay, so that's our min. So you can just look at the graph of the derivative, see it goes from negative to positive at that point, and the only one that occurs is the first graph there, so A. Alright, 84. 84 says, what is the volume of a solid obtained by revolving the region enclosed by the graphs of y equals x squared and x equals 9? Alright, let's draw that out. So, excuse me, x equals y squared. So that's going to be a sideways parabola, like that. And x equals 9, let's draw that in right there. So that's at 9. Okay, so we're revolving this thing about the y-axis. Now I'm not going to draw the symmetric side. We can get our outer and inner radius without doing that, but if you want, you could just draw a representative, let's say half a disc there, or half a washer in this case. So it's definitely going to be a y value type of problem. So we have x equals y squared. So what's the outer radius? Okay, so we're revolving around the y-axis, so it's just going to be 9. And the inner radius is from the y-axis to the first bit of material there, which is y squared. Now we need to know what we're integrating from and to, so when x is 9, we know that y is going to be 3 and negative 3 down here. So our volume will be pi from negative 3 to 3 of the outer radius squared, 9 squared, minus the inner radius squared, y squared squared. So 81 minus y to the fourth might be what you want to put in your calculator. but you'll get 1944 pi over 5 when you do that, and that is option D. Hey, you can do that. Alright, so 84. Right there. Red marker doesn't erase that well. Okay, 85. Alright, at what value of x do the graphs y equals e to the x and y equals x squared plus 5x have parallel tangent lines? Okay. Well, tangent lines, again, tangent lines have to do with the slope, where they have parallel slopes. So what you could do is take the derivative of each one, because the derivative gets you the slope, set them equal to each other, and solve it in your calculator. Okay, and that's where that'll give you the x value. So if you have y is equal to e to the x, y prime is just going to be e to the x. And the second one, y is equal to x squared plus 5x, y prime is going to be 2x plus 5. So in your calculator, just go to the solve function and set those two derivatives equal to each other. E to the x is equal to 2x plus 5. Alright, now you could graph them and trace and see where the two answers are, but the solve function would probably do it faster. So the answers it'll give you can try this out. Negative 2.45 and 2.25 are where those two are equal, and that is answer D. Alright, so I think you can get that one pretty quick. Alright, let's look at 86. Alright, 86 takes us back to the exponential growth. So it says, let y represent the population in a town. If y decreases according to the equation dy dt is equal to ky, with t measured in years, and the population decreases by 25% in 6 years, then k is equal to. So we did work these kind of problems. They weren't worded quite in this way. So let me go ahead and show you how to do it, and then I think that'll ring a bell. So let's say we have dy dt is equal to ky. We need to get back to the original equation. So if you separate the variables, you'll have dy over y is equal to k dt. We want to integrate both sides, and that would give you the natural log of y is equal to kt plus c. Okay, where c is going to be our initial population. Alright, so what you want to do to solve for y is exponentiate both sides. I think you probably remember us doing that. Well, that kills the e and the natural log cancel each other out, and now you've got an equation for y. Y is equal to e to the kt plus c, but you might remember, I hope you remember, you can bring that c out front. So c e to the kt. So you might remember this equation from radioactive decay and population declines, which is the case here. So it says we would know y over c is equal to e to the kt. It says that our population declined by 25%. So y over c would be 0.75. And that's equal to e to the k, and then it took 6 years to get there. Alright, so take the natural log of both sides. Natural log of 0.75 is equal to the natural log of e to the 6k. You can bring that 6k out front. Alright, and then I would have the natural log of 0.75 is equal to 6k natural log of e. Natural log of e is just 1. So k is the natural log of 0.75 over 6. And your calculator will tell you that that is minus 0.048. So a different way of wording it, but you've done these problems before. You get 3 minutes a problem on this section, so I think you could work this one out in that time. So that is, the answer is D on that one. And try to make sure the board is in the frame here. Okay, 87. 87, you got to realize that if h of x is equal to 4 to x of t minus 5 cubed dt. This is one of those fundamental theorem of calculus part 2. And you just, to get h prime of x, you just plug in the upper limit and then multiply by the derivative of that upper limit, which in this case is just 1. So h prime of x is x minus 5 cubed. And to find where there's a minimum, you just set that derivative equal to 0. So again, we just plug the upper limit in for t, multiplied by the derivative of the upper limit, which is 1. So where does that equal to 0? Well, our critical point occurs at x equals 5. We could check and see that it's a minimum, but you know it's going to be that. They didn't give any, there is no minimum as part of the 4 answers. But you could do a sign line if you want, but that's going to be the answer, and it's B. So that's one you could get really quick if you realize, if you don't look at that and say, oh, I don't know how to do that, it's crazy. Just plug in that upper limit, multiply by the derivative of the upper limit, and set it equal to 0. All right, so that is 87. Let's go for 88. Okay, 88 says the volume of a solid generated by revolving the region bounded by the graph of y equals x cubed, line y equals 1, and the y-axis, about the y-axis. Okay, let's draw that out. So we're just going to be looking at the upper half. X cubed goes like that. Okay, we don't care about the part to the left. We have the y-axis and the line y equals 1. And we are revolving that thing, looks like the CCA shield. We're revolving that thing around the y-axis. Okay, so I'll use my red marker that I have a hard time erasing. I won't draw the symmetric side, but if I did, you'd have a part to the left over here. Okay, this is a disc, not a washer. There's no hole in the middle of this thing. And we know that if y is equal to x cubed, this is a y problem, then x would be y to the 1/3. And our volume then would be pi. We're going from 0 to 1 of the radius, y to the 1/3 squared dy. So you probably just put y to the 2/3 in your calculator from 0 to 1. All right, and when you do that, you will get an answer of 3 pi over 5, and that is going to be C. Seems like we haven't had a C in a while, so there you go. Oh man, you could like totally get that one in just a minute probably. Okay, so 2 more. We are done with this section. 89. Okay, so it says if P of x, 0 to a, q of t dt, and the graph of q is shown above. So this is the graph of q. which of the graphs shown below is a possible graph of P? Okay, what you got to realize is that P prime of X is just equal to the graph of Q. So this graph right here, because you just plug in the upper limit, this graph right here is the graph of P prime. All right, and you can see how the graph of P prime to the left of the y-axis is below the x-axis. It's negative. All right, and then to the right it's positive. What that means, if this is a graph of P prime, okay, if that's a graph of P prime, when it's below the x-axis, that means it's decreasing. And if it's above the x-axis, it's increasing. The only one of those graphs right here, the only one that decreases from A to 0 and increases from 0 to B, because it's below the x-axis and above the x-axis, is graph D. Okay, see how it decreases